Hi, welcome to Mathematics with Tom. I'm Tom, and today we are going to make a frequency distribution, but this time we're going to make it when all we have is the data. No histogram, no dot plot, just the data. Here's how we're going to do that. So, frequency distribution. Frequency distribution. Directly from the data, directly from the data. And now, the number of classes, in our homework problems, the number of classes will be given to you. If you were in real life, you may take some time and try to see how different changing the number of classes kind of helps you to change the way the data might appear. But for now, we're just going to we'll be giving you the number of classes. So in this example, we're going to make our frequency distribution from the data, and we're going to make our frequency distribution that has 5 classes. And if we do this correctly, it should be exactly the same as the histogram in the frequency distribution we've already seen. So directly from the data with 5 classes. Okay, so if you remember, we're going to make our frequency distribution over here. And we'll do this again. So we had our frequency, we have our class boundaries. Let's start there. Class boundaries. Class limits. We have a tally. Let's put that in here. We're going to need that today. This time it's going to be very helpful. The tally, then that'll give us our frequency. And, oh, I have an idea. How about this time? This time we're going to convert our data into percentages. And so we call that relative frequency. We'll add it, this will give us something more. Relative frequency. And I'm going to put this in parentheses. In other words, we're going to be looking at, those will be a percentage for us. Okay, here we go. Now, if you remember, what we need to do is our first thing to establish is the class boundaries. Once we have that, the rest falls into place. But that's where the hard part is. And it's not that it's hard, it's just systematic. Let's do that. The first thing we need is what's called the range of the data. And the range of the data means we need to find our maximum or our highest value. We'll call it max or maximum. Minus the lowest data value. That's the amount of data that is included, the distance between them, minus the minimum. Minus our minimum data value. So let's come over here. Let's see. Oh, here's our biggest. Let me erase those. Our largest value, looks like we've got a 9 here. I see a few 9s, but I don't see any 10s. Notice that these are all single-digit data values. So it looks like 9 is our largest value. So I'm going to call that max or maximum. I'm going to abbreviate that. And then our lowest, let's see. Oh, here's a 1. Are there any data values less than 1? 1 seems pretty small. Here's an 8. That's in close. Oh, look at that right there. Right there we have a 0. So that's our minimum. so now we can find the range. So the range equals our maximum, 9, minus our minimum, 0. So our range in this case is 9. The next thing we need our class width. So our class width, and actually for the sake of space, I'm going to put that 9 over here. The next thing we need is our class width. And our class width is very simply the range it's the range divided by, I'm going to put this in parentheses, it's the number, I'm going to abbreviate, number of classes. Okay, so let's find this. Okay, so our range we found to be 9. Divided by the number of classes that was given to us. That was right there. We had 5 classes. So 9, divide that by 5. And if you put that into your calculator, you're going to come up with 1.8. Okay, but 1.8 would split data values at some point. So what do? What we do is this. We need to fix this number. This number is not ready yet. What we do is we look at our data. Notice this. Our data is in whole numbers. Because our data is in whole numbers, we round that up to the nearest whole number. Even if this was something like 1.2, we would round it up to the nearest whole number. And so again, we would have a class width of 2. So I'm going to write, let's come over here. And we need to make another note. So class width is always, in math, the word always is used very carefully, is always the same units as the data. Let me write this. For example, if the data is in whole numbers, whole numbers, round class width up, always up to the nearest whole number. Let's put one more, or if in the same ideas, if data is intense, round class width, round class width up to nearest 10. To nearest 10, and so on. Okay? Now, where do we start? Now the question is, where do we start this? Where do we start class boundaries? Where to start class boundaries? And here's what we do. We start at half of a unit below the minimum. So let me write that. Half a unit below minimum. Half a unit below the minimum. And I'm going to give you a pictorial explanation too. Notice that our lowest data value is a 0, and then it goes up to a 1, and it continues on. There's 2s and such. But if I was to continue my data to the left, there'd be a 2, a 1, a 0, a -1. Who knows, maybe there was a -2. But it doesn't matter. What's important is that we would keep our data, again, still in integer values. So, if 0 is my smallest data value, then what I'm going to do is, since these are in integer values, I'm going to start, or I could say positive and negative whole numbers. I split the difference between those positive and negative, or between a unit. So in this case, all of our data is in 1 units. So we're going to start right between -1 and 0. In other words, you could think of it as -1/2, or it's more often used in decimals, -0.5. What if these were in tenths? What if this is another example, but as an example, what if our data was something like this? Maybe our data was started at 3.1, and then after that it went to 3.2. In other words, our data was in tenths. Well, what I would do if this was my minimum value, maybe there's a couple, if this was my minimum, then I would count backwards, 3.2, 3.1, 3.0, and again, I would split the difference between the units. So in this case, my starting point would be 3.05. And that's how you pick the minimum starting value. And now we know our minimum starting value for this case is -0.5. Let's come up and we can put that on our frequency distribution. So here we go. Our first class boundary is -0.5. And it goes up to, well, here we just use our class width. What did we say our class width was? I forgot to write it down. But let's take a look. It says class width is always the units, is always the same units as the data. Well, in this, for example, if the data is in whole numbers, round class width up to the nearest whole number. Our class width came out at 1.8. So let's come over here. So we would say class width is 2. Okay, that's it. So if we take -0.5, add 2, we get 1.5. Now remember, class boundaries share a common boundary. So this is 1.5. We add 2 to that, that's going to be 3.5. We share a common boundary, so we bring that down, 3.5. 2, and then we add 2, so this is 5.5. And then we share a common boundary, 5.5 to add 2, 7.5. And if we've done this correctly, we should be able to stop. 7.5, we start with that shared boundary, we add to 9.5. Now, you know you've done this correctly if this last boundary is large enough to make sure that we get our maximum. Our maximum was 9. And sure enough, 9 would fit into that last class boundary, or into that last class. Okay, we have our classes, or we have our class boundaries. Now, you should be able to fill in our class limits. Remember what we said is, if our class boundaries were -0.5 to 1.5, our limits should actually be the values of the data inside, from the minimum to the maximum whole numbers between -0.5 to 1.5. So in this case, the first class limit is from 0 to 1. And at this point, I'm going to ask you to pause the video, take a moment, and see if you can complete the rest of the class limits. And when I come back, we'll actually put those answers up. Make sure you pause. Okay, hopefully you've got these down. We go from 2, 3, 4, to 5, 6, to 7, 8, to 9. Now is where the tally column makes sense. Here we go. We say, look over here. I have a 3. So I'm going to put a tally mark in the class that contains the 3s, right there. I have a 1. So I'd come over here to the class that contains a 1, put a tally mark. I would do that again. I have a 4. So let's come over here. The 4 would go in this third class. And then come back, I have a 1. Let's put another tally mark. Tally mark would be there. And then I continue doing this. 5. So my 5 goes there. I have a 9, a 2, and a 6. So I have a 9, a 2, and a 6. I have 5, 3, 5. Let's put those down. So I have a 5, a 3, 5. I have an 8, 9, 7, 9. I have an 8, 9, 7, 9. Then I have a 3, 2, 8, 3. Over here, we have a 3. Oh, careful now. There's 4. But my next one is going to come into this same group. So my fifth tally mark closes that group as 5. So there's 3, 2. Then I have an 8. Oh, look, here's another group of 5. 8, 3. Let's see what, 4, 6, 2, 6, 4. 4, 6, 2, 6, 4. Oops. 3, 3, 8, 3, 3, 3, 8, 3. 3, 3, 8, 3. Ooh, 2, 7, 9, 5, 0. Let's do that. 2, 7, 9, 5, 0. 2, 8, 4. 2, an 8, a 4, 284. And oh, look at that, we're our last four, 1971. So I have a 1, a 9, a 7, and a 1. Oh, look at that. And that's going to be it. That's going to close up another group of 5, and we're done. So that's how you would use your tally mark, is to just help you record a large data set. If you're taking this information from a histogram, you really wouldn't need to include the tallies. So it's from your tallies, using exactly what we just did, that then we can make the more important column the frequency. This is just a tool. The tally column is a tool to get to the frequency column. The frequency, this does not need to be included. This does. The frequency column must be included. But here we go, we count them up. Our frequency, 5. 5, 10, 11, 12. 5, 6, 7, 8. 5, 6. 5, 6, 7, 8, 9. And let's add those up. That's 5 and 12, that's 17, 8 more is 25, 31. Oh, look at that. Picked up all of our data. Now the last piece. The last piece. And that is the relative frequency. In other words, what it's saying is of the 40 data values, what percentage of them are in the first class? So let me write that down. Relative frequency, I'm kind of running short of space, but that's okay. It's of the data values, it's the percentage, I'm going to just abbreviate percentage, it's the percent in that class. Okay, so in other words, our first class has 5 data values. There's 40 total. So the relative frequency, it says you take 5, you divide it by 40, you then multiply it by 100%, and that would be your relative frequency. That's an eighth, so that's about 12.5%. And then we would continue. The next one says, well, of the 40 data values, 12 of them are in the second class. So we take 12, divide it by 40, multiply it by 100%. Well, that's going to be about 30% of our data. No, that's not right.
Yeah, it is.
Yeah, it is 30. Yeah, 30, thank you. 30% of our data. Our next one, we'd say, well, 8 of our data values are in the third class. 8 of our 40 times 100%. That's going to be 20. Yeah, 20% of the data values fall into that third class. 6. So in the fourth class, 6 of our 40 data values are in the fourth class, which is the same as 6 divided by 40 times 100%. That's going to be 15%. 15% of our data falls into the fourth class. Finally, the last class contains 9/40ths. Oops. Our last class contains 9/40ths of our, oh, that looks terrible. 9/40ths of our data. And as a percentage, that is going to be 20, I have my cameraman helped me, 2.5% of the data. Now, a quick check is always in order. In the same way that our frequency represented the total data values, our relative frequency should always sum to 100%. Sometimes there's rounding error. And so if you came here and you added to 99.9 or 100.1, that's rounding error. If it's something other than that, you've made a mistake. But let's check. Okay, I'm gonna save, let's start with these 0.5s, because those are gonna cancel. So 22 and 12, that's 34, plus a half from each of those, 35. 35, 50, plus another, oh, there we go, bingo. 100%. And that's how you make a frequency distribution directly from the data. Thanks for watching.